Hi there. In today's video, we'll be focusing on the 128 by 64 LCD display, specifically the GMG12864-06D model. We'll show you how to properly connect it to an ESP32, how to program it, and how to create a simple yet functional user interface. We'll start with a basic introduction, move through coding and construction, and finally discuss the user interface design using the LCD display. Feel free to watch and ask questions in the comments section. In this part of the video, we'll take a closer look at the 128 by 64 LCD display, specifically the GMG12864-06D model. Understanding the functions of the individual pins is crucial for correctly connecting and using this display in your projects. Pin descriptions. CS, chip select. Used to select the display in SPI communication. This pin allows you to control which of the connected SPI devices is active. RSE, reset. Pin for resetting the display. Used for initialization and restoring the display to its default settings. RS, register select. Used to select the register for reading or writing data. It distinguishes whether the data is a command or text to be displayed. SCL, serial clock line. Clock line in SPI communication. Synchronizes data transfer between the microprocessor and the display. SI, serial input. Data input line in SPI communication. Responsible for sending data to the display. VDD, power supply pin. Provides voltage to the display, typically plus 3.3 volts or plus 5 volts. VSS, ground pin. Connects the display to ground, which is essential for proper operation. A, backlight anode. Used for backlighting the display. Connects to the power supply through a resistor to control the brightness of the backlight. K, backlight cathode. Responsible for connecting the ground for the backlight. Now let's move on to the practical aspect of our project, which is connecting the 128 by 64 LCD display to the ESP32. In this step, we'll show you how to connect all the necessary pins step by step to facilitate the visualization of the process. Power supply. Connect VDD to pin 3V3. Connect VSS to pin G and D. Display control. Connect CS to pin GPIO5. Connect RSE to pin GPIO21. Connect RS to pin GPIO19. Connect SCL to pin GPIO18. Connect SI to pin GPIO23. Backlight. Connect A to pin 3V3. Connect K to pin G and D. IC pins. IC SCL, IC CS, IC SO, and IC SI are not used in this project. They are for an alternative communication interface, which is not needed for our setup. We use different pins for the display's basic functions. In this part, we will create a simple program to display text on our LCD screen. We will start by showing a basic message to encourage viewers to subscribe to ElectroHub. Let's dive into the code and see how we can make this happen. In the setup function, we start by initializing the display using U8X8 begin. Next, we set the contrast to 1 using U8X8.set contrast 1. Adjusting the contrast helps us ensure that the text is clearly visible on the screen. After that, we clear the screen with U8X8.clearDisplay to make sure there is no residual data displayed. Then, we set the font using U8X8.setFont. In this case, we are using a simple 5:8 font, which is suitable for our display. Finally, we display 2 lines of text using U8X8.stringDraw. The first line is subscribe to, and the second line is ElectroHub. These strings are placed at specific coordinates on the screen to make sure they appear correctly. Notice that the loop function is empty because this program is meant to display the text just once and doesn't need to update continuously. In this section, we will extend our previous program to include input from 3 buttons. The goal is to detect whether each button is pressed or not, and display this information on the LCD screen. This will give us a simple way to interact with our display using physical buttons. In the Setup function, we start by initializing the display and setting the contrast, just like in the previous example. We also set up the font we want to use for displaying text. This time, we're using Chroma 48 Medium 8, which is slightly different for better readability. Next, we define 3 button pins and configure them as input with pull-up resistors using pin mode and input pull-up. This means the buttons will read high when not pressed and low when pressed. In the loop, we read the state of each button using digital read. We check if the state of any button has changed compared to the last known state. If it has, we clear the display and show the current states of the buttons. We use drawstring to display the text ElectroHub at the top, and then print the status of each button on separate lines using U8X8.print. We then update the last known states of the buttons to the current ones to keep track of changes. The delay at the end of the loop is added to prevent the program from reading the button states too frequently, which helps in debouncing the input. In this section, we create an interface that allows us to switch between 3 layers and edit values using buttons. We have 2 modes: View mode for navigating layers and Edit mode for adjusting values. In View mode, you can use buttons 1 and 3 to move between layers. The currently active layer is shown with its value and a layer label at the bottom. Pressing button 2 switches to Edit mode, where buttons 1 and 3 now decrease or increase the value of the selected layer. Press button 2 again to return to View mode. To sum up, this project demonstrates how to create a simple user interface on an LCD display using the U8x8 library, allowing you to navigate between layers and adjust values using buttons. With intuitive feedback on the display, you can easily switch between View mode and Edit mode to either observe or modify values. This approach is ideal for projects where user interaction is essential. If you found this helpful, be sure to try implementing it in your own projects. Feel free to share your feedback or any ideas you have for improving the interface. Keep exploring and stay tuned for more exciting tutorials. Don't forget to like the video and subscribe to our channel for future updates.